Hey everybody, we're on 7.3, dividing with exponents. So we're using what's called the quotient rule. So quotient is another word for division. So the division rule, if you prefer that. Okay, so first we're going to do kind of the same thing we did before, is we're going to expand and see if we can come up with a pattern. All right. So here we have on the top, we have 3 to the 5th. Well, that's just 3 times 3 times 3 times 3 times 3. And on the bottom, we have 3 to the 3rd. Well, that's just 3 times 3 times 3. We kind of did this last time where if we're dividing, we can cancel top and bottom. And that just leaves us with 3 times 3, or 3 squared. Okay. Do a couple others. So top we have 2 times 2. On the bottom we have 2 times 2 times 2. We can cancel, and that leaves us with, again, if we cancel everything on the top, it'll just be a 1 on the top. So 2 over 1. Or you could say 1 over 2 to the first if you prefer. And here we have 7 times 7 times 7. And on the bottom we have 2 times 2. So here again, these are not like bases. Obviously we can't cancel a 7 and a 2. So that would be all done. We can't simplify that further. All right, here's some variables. You're going to have more variables on your homework and your test than what we did previously above. So here we'll just expand x times x 5 times. On the bottom we have 2. Cancel, cancel. That leaves us with 3x's, or x to the 3rd. So I hope you're coming to kind of coming up with some sort of idea of what the rule is when we divide like bases. What do we do with their exponents? Coefficients, you do the same as you would normal. So we divide as normal. 6 divided by 2 is 3. And then we have 3x's on the top, 1 on the bottom. And that just leaves us with 3x squared. All right. And then again, this is another example where we have bases that are not the same. So that means we cannot simplify that. Okay. All right. So just looking at these two and the ones that we did above, what is the pattern? What do we notice with their exponents? When we are dividing like bases, what happens with their exponents? How can we do 5 and 2 and end up getting 3? How can we use 3 and 1 to give us 2? So what are we doing here? Okay, so I hope you're realizing that when we divide like bases, we subtract their exponents. When we divide like bases, they have to be the same, like x and x or y and y. We subtract their exponents. Okay? And just realize that we always, when we do this, we do the top minus the bottom. So 5 minus 2 is 3. 3 minus 1 is 2. Let's see if it works for these other ones too. 5 minus 3 is 2. 2 minus 3 is a negative 1, which means we'd need to bring it to the bottom and change its sign, which we did here. 3 minus 2, but wait, we can't because they're not the same. Their bases are not the same. Same as this one. We can't do that. Okay, so here's kind of like this is kind of like with words. And with like a little equation, it's kind of like this. So if we have something like x to the a, where a is some number, it could be 2 or 3, and we're dividing it by something that has the same base, but a different number, or it could be the same number, okay? Then we're going to do x to the a minus b. We subtract their exponents, top minus the bottom. So again, another example could be something like 10 divided by x to the 6th, well, that would be x to the 10 minus 6, or x to the 4th. Okay? All right, so we're going to do the same thing we did before. We're going to expand. Really, I'm not picky. If you just want to do the rule, that's okay. I'm going to do the expanding and just like using the shortcut, like the rule that we did right here. You can do it that way too, either way, okay? So one way you could do is to expand, so that's 3 3s on the top. And on the bottom, we have 2 3s on the bottom. We cancel, that just leaves us with 3. If you were to use the rule, like this little expression kind of thing up here, since we are subtracting or dividing, then we're going to subtract. So that would be like 3 to the 3 minus 2, or just 3 to the 1, which is just 3, okay? So, same thing. And I imagine eventually you'll be good enough, or that you'll just be able to look at these two numbers, subtract those in your head, and you'll say x to the 2. 5 minus 3 is 2. Okay. So here I'll expand it if you prefer that. 5x's on the top, 3x's on the bottom. Cancel, cancel, cancel. All we have left is x squared. Okay. Here's another example. We'll expand 3 times x over, we have 3x's on the bottom, so we cancel one of those, and that just leaves us with 2 on the top and x squared on the bottom. Okay. If you use like the shortcut, here we have like a x to the 1. If we were to subtract, here we'd get 2x to the 1 minus 3. Well, that's 2x to the negative 2, and we'd need to bring that to the bottom and change its sign. So we'd end up getting 2 over x squared, which is the same thing we got before. All right, the other side. Let's see. Give some of these a try if you'd like. Pause and give these a try. These are a lot like your homework. Okay, so here we have 9x to the 5th. So if we were to expand, then we would do, hang on, we got this negative here. So remember, if you're going to expand, you've got to get rid of your negative first. So if we have a negative, that means we can bring it to the top and change its sign. So we'd have 9 thirds. I guess we could simplify that up too. I don't want to do that first. So 9 thirds is the same as 3. So we could have 3, and then we had that x to the 5th, and then we're going to bring this up and make it be positive, so x to the 2. And then we could expand. So 3 would have 5 x's, and then 2 more x's. That would give us 3x to the 7th. Okay, so that's if we want to expand. If you don't want to expand, okay, then we can just use that subtraction rule. So if we're dividing like bases, then we just subtract them. So we still have this 9 divided by 3 is 3. And then we do x to the 5 minus, since they're being divided, we subtract. But we're subtracting a negative 2, so that would give us a positive, if that makes sense. So the negative and the negative will give us a positive. So we'll get 3x to the 7th, which is the same. Okay? Again, you choose which way you want to do it, it's fine. So like this one, we could do x times x. Here we'd do 6x's. And then on the bottom, we'd have 3 x's on the bottom. And then we'll just cancel as many as we can. So 1, 2, that didn't go very well, 2, 3. So that leaves me with 5 x's left. So x to the 5th. Okay, if you were to do the other way, you'd probably want to, since these are being multiplied, we would add those first, and then we would subtract the 3. So that would be x to the 2 plus 6th. So that's x to the 8th. And then we could subtract them. So that would be x to the 8th minus 3, or x to the 5th. One way you really could do this is you could just say, well, since these are on the top and they're being multiplied, we'd do x to the 2 plus 6. And then since this is on the bottom, we would subtract 3. And then you'd get x to the 5th. Same thing. Okay? Really just depends on what you prefer, and just stick with it. All right, so here I'm just going to expand this all out. So 3 over 6, and we have 2 x's here, and then 4 x's here, and then 2 x's here, and then 5 x's here. Cancel, 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 cancel. And that leaves me with 3 over 6x. But we can simplify the coefficients, the 3 and the 6. That's just the same as 1/2. Right. Couple more. If you're feeling good, then you could probably just skip to 9 and 10. All right, so here we've got, another thing we can kind of see is that we have an x to the negative 2 and an x to the negative 2. Those could cancel. But if not, then you could expand. But if we have these negatives, we need to move those so that they change their signs. Again, there's lots of different ways to do this. Since these are being multiplied, we could add those exponents. Maybe we'll do it that way. So negative 2 plus 3, that gives you x to the 1. And on the bottom would do, since these are like bases and they're being multiplied, we add those. That would give us x to the 3rd. And then if you wanted to expand, you could. So x over x times x times x, and that would leave us with 1 over x squared. Okay. The one thing that you've probably noticed that there's different ways and different orders to be able to solve these problems. And in some ways, it's hard because it's not like these are the steps, you just need to follow them, and you'll get your answer, okay? But one thing I would say again is that you stick with the way that you do it, okay? All right, last but not least, again we can cancel. Those are our coefficients, or not cancel but simplify. Negative 4 divided by negative 2, that will give us a positive 2. And then if we just want to keep that there. And then we could expand 2x times x over x. One of those will cancel, and that just leaves us with 2x. All right. And then this is kind of like when we did before, but now we're trying to find a missing side. We're going to use the same area equation. Area is equal to length times width. Okay, here they give you the area, and they give you maybe the length. So we plug that in, we end up getting x to the 3rd, y to the 7th is equal to x squared, y to the 4th, times the width. And that's what we're going to try and find. We're going to try and find this width. So to do that, what we're going to need to do is divide both sides by x squared, y to the 4th. And then now we have a problem that we've done just recently of something very similar. So since they're dividing, we'll subtract their exponents. So we have x's. We'll subtract 3 minus 2. That gives us x to the 1. And then we have our y's. So again, we subtract 7 minus 4. That gives us y to the 3. So this width is x1 or x, y to the 3rd. And if you were to multiply these two together, that would give us our area. All right, so give this one a try if you would. Same sort of thing. Really, if we're going to find that missing side, we're going to say our area is 30x to the 10th. Our length is 6x to the 8th. And we're going to multiply that by the width. We just need to solve for the width. So we'll divide both sides by 6x to the 8th. And we get width by itself. We just need to simplify it. So 30 divided by 6, that is 5. And then we have the same base, x and x. So we subtract their exponents. 10 minus 8 gives us 2. All right, please let me know. Shoot me an email if you have any questions, or stop before or after school. I'll help you out, okay? See ya.